Hello everybody and welcome back to another episode of Math with Mr. Emond. Today we are going to be continuing on in our unit on linear and quadratic inequalities. We're still focusing on inequalities in two variables, but today we're going to be looking at quadratic inequalities. So it's going to be very similar to the last lesson where we're dealing with less than or equal, greater than or equal. But now we have things that quadratics in general form. But remember, we may also see vertex form, which just as a reminder looks like this, right? That's vertex form. And so we probably could see those. Remember, we're kind of dealing with real numbers unless otherwise specified, which means we're going to be shaded in. When we're dealing with word problems and stuff where you can't have negative numbers and you can't have decimals, we might be dealing with some whole or natural numbers there. And that's about it. Apart from that, it's going to be very much the same as the previous lesson. So let's look at this quadratic here. Y is less than x squared minus 2x minus 3. Well, the only thing you would have to do for this is first graph the related quadratic, which is y equals x squared minus 2x minus 3, which has x intercept at -1 and at 3, and a vertex at 1 and -4, and then you just graph it from there, right? It's a dashed line. Why is it a dashed line? Because it's less than, not less than or equal to. And then what you might have to do is from that point on, choose a test point from either above or below the parabola, or I like to think of as inside or outside, okay? One of those regions. In this case, a good spot maybe to kind of pick is this one right here, 0, 0. So let's try out 0, 0 and see what happens. 0 is less than 0 squared minus 0 minus 3. So is 0 less than -3? And the answer is no. So that green highlighted spot is not part of our solution set or solution region, which means we would shade outside the parabola, which has been done here. So that's kind of it for an introduction. Let's go ahead and actually try some practice problems here. We're going to graph this quadratic. So we have the vertex, right? This is vertex form. The vertex is 3 and 1. So 1, 2, 3, and 1. There's our vertex. And our a value is -2. So I know normally my quadratic, I'll draw what normally would happen. You'd go 1 and 1, 2 and 4, right? And then 3 and 9. So there's 9. So this is what a normal quadratic's points would look like. We have it by a factor of 2. So all of these are going to multiply by 2. So rather than going down 1, we're going to go down 2. Rather than going down 4, we're going to go down 8. And rather than going down 9, we're going to go down 18, which is going to be off the graph there. So not actually going to do that. And we plot our points. And so there's our quadratic, right? And so it's pretty easy as long as you know these things. And or if you need a refresher on this, go back to the quadratic unit. But you can see I don't really need to do a table of values. Just by understanding what the a value does and comparing it to my normal x squared points and multiplying them by 2, I'm able to come up with this graph very quickly. And so now it's less than, so this should not be a solid line. So I'm just going to take out the eraser now, and I'm going to make it a dashed line. All right, so there we go. We have a dashed line. And now we need to test some points. And so, you know, a good point to test is this one right here, outside, right? And that's going to tell us if outside of the parabola is part of our solution region or not. So we have 0 is less than -2 times 0 minus 3 squared plus 1. So is 0 less than -2 times -3 squared plus 1, which would be -2 times 9 plus 1, which would be negative 18 plus 1. So is 0 less than negative 17? No, it's certainly not, which means that our solution region then must be the inside. So we're going to shade the inside. And there we go. Problem achieved. Determine if the point 2, negative 4 is part of the solution. So here's, let's take out a different color here. 2 and 1, 2, 3, 4 is right there, and it is. Okay. Example 2. So this one's a little bit different. This was given to me in vertex form. This is now in quadratic, in standard or general form. So we're going to have to do things a little bit differently this time, but it's all going to be the same. Don't worry, right? So what I would probably start with is factoring. So this is going to be x minus 5, x plus 1, which means our x-intercepts are x equals 5 and x equals negative 1. So we can go ahead and plot those. Negative 1 and 1, 2, 3, 4, 5, which means this is my center point. So my vertex is going to lie on this, and this is x equals 2. So let's plug in x equals 2 to find our y value. So this is 4 minus 8 minus 5, which is negative 4 minus 5, which is negative 9. So negative 9 would be right here. So there we go. We can, ooh, that's kind of terrible. We can graph it from this point. So I kind of missed the mark there, but that's okay. So there's our graph. Now we're looking for inside versus outside. So we can test that point, 0, 0. Let's go ahead and do that. So is y greater than or equal to negative 5? This one's easy, right? Because you put in the 0 here, that's 0 and 0. So all that's left is the negative 5 here. And of course, this is a 0, not y. Is 0 greater than or equal to negative 5? Yes, it is. So that means that this point right here is part of my solution region, which means I'm going to shade inside my parabola. Okay, and that's basically it, right? One thing maybe to recall, so I found my axis of symmetry, right? By looking at the center point between my two x-intercepts. So I just counted, and that's how I found my axis of symmetry. And your vertex is on the axis of symmetry. So I used that x value to find my y value. Remember that you could also do negative b over 2a, right? And this is going to be your x value as well, okay? So just to demonstrate that, our b value is negative 4, so you have negative 4 over 2 times our a value, which is 1. So this is 4 over 2, which is 2. Okay, so there it's the same. My x value was 2. Now what you would do is you would take this value and you would plug it in just like I did, right? So if for some reason you can't determine exactly what the axis of symmetry is, visually, because you're dealing with like fractions or something over here, just remember negative b over 2a, and then plug that answer in to find your y value, and you have your vertex. All right, it's going to be your turn. Go ahead and try this one out, and I will see you in a minute. Okay, welcome back. I have the solution for you, so let's take a look at it. So the first thing that I did was I factored it, and that helped me find my x-intercepts, and I plotted those first. So there they are. And then I kind of realized that this x equals 1/2 is going to make my axis of symmetry kind of hard to find. Just like I kind of said, sometimes it is. You can't do it visually. So that's where you should know to do the negative b. So my b is 5 over 2a, and my a value was 2. And that's going to give me negative 5/4. Then I take this number, negative 5/4, and I plug it into my normal equation. And so I plug it into this. And then I used my calculator, so you can take a look at the calculator on the right, to find the y value or the q value of my vertex was negative 6.125, and that's right there. Now, if you wanted to plot more points than this, you're certainly welcome to. All you would basically do is put in values. So like, for example, when x is 1, you would have 2 times 1 plus 5 minus 3, which is 2 plus 5 minus 3, which is 4. And when x is 1, it's 4 right there. So you could plot a couple points, right? And just to make sure that your graph is super accurate. And that's basically it for graphing, right? We've learned all these tricks already. So I know I'm kind of flying through them, but it's assumed that you've watched the previous videos and you know how to do this. So then choose a point in the solution region to check the original inequality. So I picked the point 0, 0, and I found that that was false. So that means 0, 0 is not in the solution region, which means I shade outside, which I did. Okay, so that's going to be it for this lesson. In the next lesson, we're just going to do a couple more practice problems, and that's going to be it for the lesson. So see you in the next video. Bye-bye. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.